The workshop is going to be presented by Alejandro Serrano. He is not only a contributor to the backend framework Haskell. Recently, he joined also the world of front ends. Since he likes to very much give trainings to functional programming, now he's going to train us how to develop an app for the browser. I hope you all have installed your Nix package manager. So Alejandro, I'm looking forward to an informative workshop.
Yeah, thank you. Let me share some slides I have for the beginning. So yes, indeed. I mean, I've been doing Haskell a lot, but since a few months, a colleague of mine sort of introduced me to the beautiful world of PureScript, and I've like found a bit of love again for front-end development, which is something I did this like 10 years ago, and it was a time where you have to change the DOM and you have jQuery and things like this, and it's like, I don't want to do this anymore, and now things have become much better. And as part of this, I discovered Miso, and I actually really got in love with it because it's something which allows us to do Haskell in the front end. So as Sergey said, this workshop is going to be sort of interactive. That is, I'll tell you a bit, and then you'll have time to work on some exercises. We're going to build something together, and then I'll go back. So sort of my idea is roughly this is going to be like 5 blocks of 30 minutes, a bit more, where essentially I'll like talk for 15 minutes, and then you'll work for 15-20 minutes on stuff. And in the meanwhile, you can either ask in the Slack channel or ask in the Zoom session any questions you have also while doing the exercise. So that's the idea for the workshop. Not me talking 3 hours, that could be quite terrible, but actually you doing something. And I hope that's, a good way to start or end your Friday, depending on your time zone. So for me, it's going to be almost the end of the day at the end today. So a nice way to end your day. So yeah, I said Miso. So, well, first of all, again, welcome everybody. And maybe you haven't noticed, mostly if you're a Haskeller and then you are following mostly like more the backend side, the service side, or the things which are happening in blockchain programming too. And maybe you know that you have Haskell and Scala and all these kind of languages seem to be entering the mainstream. But while we were not looking, at least for my surprise, functional programming is also slowly entering mainstream web frontend. I mean, you look at frameworks as React, which is now the go-to framework, and it actually uses functions as components, and it has this. You have Redux, for example, which brings this idea of folds to this kind of things. And you even have languages like PureScript, which bring directly OCaml to the JavaScript world, and you can actually use this to create your web applications. So why not bring our favorite tool along? And just for safety, I'm in Haskell, of course. That's a favorite tool of mine. So Miso itself is an opinionated framework for doing web frontend in Haskell. And I think the 3 things actually make this kind of experience quite nice. So it's you use Haskell, so you can use almost any library you love from Haskell. You're doing web frontend, so you are actually doing something which is recognizable to people who are doing, as I said, modern web programming. And it's also, it doesn't allow you to do a lot of manipulating things. It is opinionated on how you structure your application, which I think also gives you, it takes some of the freedom, but it also allows you for an easier and nicer programming experience. Miso itself is built on something called GTJS, which is a backend for compiling Haskell to JavaScript. It's essentially, a way to spit out JavaScript from JHC. And itself, and Miso on itself is based on a concept which is nowadays use anywhere, where you essentially have like a virtual DOM where things take place. You create a view, and then this is applied to your actual web page. We'll see how it works, and also this idea of having one state which is updated every time something happens. So you click a button and then there is a new event, and this changes the state, and this essentially means that you have to refresh the page to show the new state. And as I said, if you've seen how React and Redux work, among others, among the Elm like Elm with the Elm architecture, or PureScript with Allogen, they all work in the similar fashion. So more about the workshop. As I said before, the idea is to have blocks of explanation followed by exercises. So the deal is gonna be, I built the boring notes app. So it's like more like a to-do list. So that's like the typical example. I built a to-do list that's boring, and you have to do the fun part, which is build a tic-tac-toe game. And that's what your part is gonna be. So at the end of everything, you will have a working tic-tac-toe you can use to play with your friends. And this is more or less the parts in which we're gonna talk about. So first, I'm gonna start talking about basic views and events. Then we'll have some exercises, then forms, exercises, local storage, and that's actually a way for me to introduce what it's called effects in this library. Then requests, in which we are actually going to use servant but on the client, which is a very cool feature. And then routing, which is again just a way for me to introduce another concept from the framework called subscriptions. So that's the idea. Something you might have noticed that I've been stressing all the time, that you should install Nix before you start this workshop. And I want to give you a bit of the reason why I was stressing this so much. So the thing is, I mentioned that Miso uses GHC.js, but setting up this in your machine turns out to be quite complicated. GHC.js is actually a quite complicated piece. So for example, it lags behind the latest GHC version. So it targets in particular 8.6.5, which is not a problem at all. I mean, we don't need any new features of 8.8 or 8.10 for this workshop, but it just gives you an idea of how complicated it is to upgrade GHC.js on the moving target, which is the GHC release cycle. So the easiest way to have everything set up is to use Nix. Nix is a package manager. I'm sure you have heard about it. And it focuses on reproducibility. And in particular, this is quite useful for us, because you know that if you have Nix and I managed to get a GHC.js installation on my machine, I can give you my Nix file and it works on your machine. So that's essentially what's happening here. If you keep using Miso, you might need to tweak the default Nix, that the Nix file where the build is explained. So you might need to tweak this, but for this workshop, everything is done for you. So if you don't have Nix, get it now. That's the line you need to type. I'll give you like 20 seconds for copying it. Yes, I know it's curl pipe sh, but that's the best we have. And if you happen to have Mac OS Catalina like I do, then this is not valid. But if you execute this, it will actually tell you how to do this. So there is some, with all the new restrictions they've introduced, you need to do something which essentially creates like an unprotected partition and things like this. This is all automated, but it does some scary things. So it asks for more permissions. Okay, so don't worry if you don't have Nix, and you didn't have time to copy this. You'll have time during the whole workshop. It takes long to install, but we have 3 hours, so you'll have enough time to get Nix at least. So let's go into basic Miso. let me just have a couple of slides to introduce the main concepts, and then I will directly jump into code, because this is something I haven't mentioned, but the format of the workshop, apart from me explaining and you doing exercises, it's going to be essentially that I code the application. I will start with a very simple application, and then we'll build from there. So you can see everything which is moving. So I don't want to show you that like a snippet of code of what you want to change. I really want to show you the whole experience and what you need to change here and there, because well, at the end of the day, all the parts in a web app are somehow interrelated. So Haskell actually gives a very nice developer experience in this regard, because you change something here and then, oh, it points you that you should change something over there. So I want to show you the whole picture. So it's going to be most of the time of explanation, me coding. But first, a few concepts. So for a Miso web applications, you need to define these 5 building blocks, and they are quite are essentially what you require to manage any stateful application. So you need to define 2 data types. One is going to be the model, which defines the shape of your state. So let's think about the tic-tac-toe application I'm going to ask you to build. Well, you need to have the state of the grid, and then you need to have the name of the players. And that's the state. So you need to define a data type which holds this information. And then as I said, when you have an event, then an action is going to be performed over this model, and you also have to define which are the actions that may occur. So for example, in the case of the tic-tac-toe game, it could be like start the game or clicked on this point in the board. So these are the actions which might change the model. Then you need to define 3 different functions. One which is not actually a function, it's like, well, it's a function but without arguments, which is the initial model, so how your application starts, and then something which turns your model, so this information, into actual HTML, and this is called the view. And what it's going to happen is when you define this view, you also define how HTML events, so think of like when you click on a button or a text changes, these will raise events in the browser, and these are turned into actions. These actions are what change the model. And then you have the update, which is the function which essentially taken the model, and one action gives you back, gives you the new model. So as I said, this kind of architecture is shared among many different frameworks. So I was actually able to steal an image from a nice web post about the Elm architecture, which is kind of a similar architecture. And here you can see what's happening. So you essentially have the model, which is the state, what you define, and then you have the HTML, which is what is shown, and then you have this. You start with the initial model, and then you have this cycle of you show the view, this creates new HTML, HTML raises a new event, which is turned into an action, which are called messages in Elm. That's what it says, MSG. And then with the new model, creates a new model, and you go into this cycle until somebody closes your browser. And then you will actually get an event on browser close. So the cycle will ultimately end. So I've mentioned this, how it's similar to other frameworks, and just to stress this, I mean, building HTML here is going to be very similar to what you do if you use the React JavaScript framework. It uses this same idea in which you actually define what your HTML is for every state, but actually it's not that the whole page is refreshed on every cycle. It uses this idea of DOM diffing, which essentially is, okay, I take the DOM you had before, so that the information in the web page you had before, and the new HTML that you wanna show, and then I do a diff, and then I only change the tiny bit that changed. So that means that if, for example, you change something from normal font to boldface, then only this tiny change is applied, even like the whole view is produced. And this is what people call the virtual DOM, or this like DOM diffing. And state management is very similar to Redux. In Redux, the model is what they call the store, and the date function is your reducer. And that's because if you think about it, that's essentially like a fold or a reducer. You start with an initial value, and then you are folding over your actions. And something which Miso doesn't have, and sometimes it's actually something you miss, is having no local state. So what you cannot define right now in Miso in an easy way is something like a small component which has its own local state, which is not exposed to the outside. You really need to have a whole state for the whole thing. So that's something which, if you make bigger applications, well, you end up like sort of replacing somehow, but that's not like built into the framework. Good. So let's like just jump into the code. That's the web, the place where you can download the code, the exercises, everything is gonna be there. But if you wanna also follow along with the code and look at the code, you can do it now, or I'll show it later when you need to have the exercises. So let's see. Yeah, I wanna show a different screen, which I guess is. So I hope now you're seeing Visual Studio Code instead of like. Yeah. So this is the start application. The application will begin with. Oh, no, it's okay. That's the application will begin with. And by the way, of course, if you have any questions along the way, just type it on the chat. I have the chat like in another screen, so I'll see what you're saying. So the result of this, if I run nix build, if I actually type here, no, it's in the right folder. So this has just been built, so I can open it, and it will open. It will open. Sorry, it opens in another different window. So, so this is how now you should see the browser window. So this is how it looks like. So it's like just a to-do in Miso, and what you have here is tasks. So now you cannot create new tasks. You cannot do anything. You can actually click here. But if you see, I have now the fact that when you have something which is done, then it's slightly more gray. But this doesn't change when I click. That's because I don't have the events going on. So let's look at this code, and then we'll start changing some of these things. So let's go back to the code. So here we are. Maybe I should. Sometimes it's hard to have everything in the right place. Sorry about this. So here is the code. It starts like a normal, sorry. Let's see if I can. Yeah. Now it's good. Now my setup is okay. So it starts as usual, and as I said, you have to define two data types, and these are my data types right now. My model, it's gonna be a list of items, a list of list items, and then each list item will have an ID, some text, and whether it's done or not. So that's how we define a list item. You will notice that I'm using this Miso string. That's a special string that's like a JavaScript native string. So you can also use like string or text, but in this case, it's just easier to just directly use Miso strings. so you don't have to do any conversions. And the good thing is because by using overloaded strings extension, you can actually have string literals being directly Miso strings. So that's my model. This is my model. That's the first building block. The second building block are my list of actions. So now, because there is no interaction, there is only one, which is none. And the fact that I have one is because when you start your application, you also need to tell what is the starting action. So I'm just having like a known action, which, as we'll see later, is sometimes useful when you have to say you have to do something. Like imagine you have to click and then you have some logic and decide whether you want to do something or not. The easiest way to get around the fact that you don't want to do anything is just have an action which ultimately does nothing. On top of that, I need my initial state, which is going to be this. Those are my initial items. And then I need a way to update my model. As I said, it takes the action and the model, and we'll see in a bit why instead of just the new model, it gives me effect action. Well, spoiler alert, it's just going to be a monad, which allows us to do IO actions. So that's how you can do other stuff. Of course, IO actions are not IO actions like in a computer. It's going to be like browser-based IO actions. So things like console log or show with an alert, things like this. But that's like what effect does. And we put everything together here in the main. And usually you don't touch this, but you start the app. And here I'm using this special record wildcards, which essentially I put ... And I need to have like a list of fields, but it gets the names from this where clause here. So that's where I define everything. So you can see that my initial model is going to be initial items. Then I start with the initial action none, and then I have something which I just kept on the default. So if you go to the Miso documentation, you can copy this block that those are the defaults. For example, mount point is if you can actually make this work on not on the whole web page, but just on a part, and that's like the mount point, things like this. So what I haven't shown yet is the view. So how this model is translated into HTML. So here it is. Here is my view model. So it's as simple as really from the model returning a view, and this view is just a bunch of HTML. It's just for ease of use. The library defines all these helper functions like div underscore. They are all like thing underscore, which are exactly the same HTML element that you will use, and they all take like the attributes and then the content as a second argument. So, for example, here my whole view model is be on a big div where I have my header. And that's something which is I find quite nice because these things are just Haskell values. I can just take any part and turn it into a function and turn it into a different value. So the header is here. So that's what shows the big to-do text. And then in Miso, so this is the header. How you get to this HTML is a different question. So I'm using this Bootstrap CSS framework. Which has a few classes and sort of has enough documentation to let you know how you write this. But like for the exercises, I give you all the HTML, so I don't really want you to fight the HTML. But that's like normal HTML. If you are doing web frontend, you ultimately need to write the HTML. And then I have a list group, which is an order list with this class, which make it look nicer. And here again, I'm using normal Haskell code to say, well, map over each element of my model, which if you remember is this list of to-do items, get me a view list item to make up the list inside my order list. So again, we can use normal Haskell ideas to encode things I did, like recursion, like iteration over these things. So if you look at other web frameworks out there, some like try to do this, and for example, React takes also this idea of just use a higher order function like map to get to build your components. And then every of these list items, again, is a big thing, but essentially this is creating a new list item. That's what li does. And inside of it, I have a checkbox. That's what the input type checkbox does. And a label. But here you can start seeing something in which I'm actually changing the view depending on the actual data. So up to now, everything was more or less static. But here, depending on whether my list item is done or not, I have the check value being the right one. So this will be true or false, and it will tell you whether it's check or not. I'm also using the ID to write to like be able to go back and know which thing has been clicked. And here I have this thing which says if it's done, I will show the text muted. So that's why it was gray, and otherwise I don't. And then I show the text, which is the li text. So this for doesn't have to do anything with like for comprehensions or for loops. That means that this is a label for this checkbox. So that's the way when you click on the text, the checkbox is changed. That's how HTML sort of does this. So yeah. So let's start. And what we can do is first of all do something that makes you when the thing changes. So when you click on the to-do item, I really wanna change the style. So for this, what I need to do is to essentially toggle the state, and so if I change my model, then this will refresh and change it as required by this. So let's do this first, because I think that's the easiest thing we can do to see how everything needs to like be put together. So first of all, we have to think, okay, what is an action which has enough information for me to know what thing needs to be done? So at least the way I think about it is just, well, add a new action that's like toggle state, and then I need to know which of the many items to change. So I can just, I don't know, like toggle list item ID, that's gonna be the Miso string. So that's the new action, right? Now I had before what to do for none, but now I wanna do a new one, which is if I have a toggle state with with some toggle ID applied to the model, which, if you remember, that's the list of items. Well, what I can do is say, well, the new state is going to be essentially mapping, or just like flip map m. You will see me writing flip map a lot of time, because most of the time you just want to do something on the list, but the other thing gets quite big. So, and then what I'm gonna do is simply pattern match on the list item, and then, well, if the list if the list ID is equal to the toggle list ID, then I just recreate it. So I say that li done is not li done, else I just keep it the same. So that's the new thing. And then finally I return this, and I mentioned you have this thing working on this effect monad, so you cannot just return it like it. In this case, you usually use no f instead of pure, which is a better way. It's like a more semantic way to say no effect. So and it will, here I guess it will tell me, oh, redundant flip replace, yeah, hlint is right, but I wanted to write this. So now we have the thing which so we have the new action and what it has to do to the new to the state. So we are just changing the one which has the same ID. And now the last part is connecting this to the actual HTML. And how we do this? Well, we go to the view. That's where I mentioned we were going to do this. And then I say, well, when this input changes, then I have to mention what is the action. So in this case, we just say, well, toggle the state of what the LID. So that's the one we want to do. And you see that by using the ID here, we are able to piggyback on the other things. So let's hope this builds. Otherwise, I would be very embarrassed. So it's not the fastest thing in the world, but yeah, it says linking, so it worked. And now something you have to remember if you're using Miso in this fashion is that you cannot go to your browser and just refresh. You need to open the result again. So like using this open result again, because this is actually a link. So it's a symbolic link to your latest version, which is going to change every time you recompile because your sources change. So if I do this and now I share my screen, that's the new tab, which is the new version, then you can see that if I change, then it's very slight, but it changes from gray to black and the other way around. So we actually did our first event handling in Miso. Yay! Cool. So, now we are pumped up. Yes. We need a button to create new text. That's what we need. That's like, okay, let's go back to the code. There is no time to lose. We need to figure this out. So let's see. Okay. I don't want to tell you about forms yet because forms are complicated. So let's do something even better, which is being able to have a random task every time you want. Yeah. It's Friday, might be a bit crazy at this point about what is a good idea, but that's what we're gonna do. So let's see. So again, the first thing we can do this in many different ways, but let me start again by first doing the actions, then the update thing. That's usually the easier part if you are a Haskeller, and then trying to change the front-end code. And the nice thing is I have here my notes about how I should change. So because getting the HTML right is something which is not type checked. So I mean, it's type checked that you have the right types of elements, but it doesn't mean that the thing will look actually okay. So okay, what we're gonna do is have a new thing which is gonna be random to do. That's the new event. So when I click, the random to do thing happens, and then I want a new random to do to be done. So good. So randomness. So okay, that I need to import system.random. It's not there. Okay, let me change my Cabal file. I'm just showing you this to see that it's actually the usual Haskell workflow. I need a new package. I add it to my Cabal file, and that's all. Okay, so I'm gonna use system.random. Great, and just because otherwise we'll have everything being just the same random things, I'm also gonna add the time. So let's add the time. So let's add the time library there. Great. And then I also need to import data.time.local time. Great. We even have some completion thanks to the awesome work of the Haskell language server people. So good. So let's look at this. so we have a random to do, and now we have to write the update model. So update model, it's gonna be random to do m. And now here is where things turn a bit complicated. So actually, you would expect things to work in this way, sort of. You first do the effects and then you return, but that's not how things actually work. You first return the new model and then you do the effects and then go back to a new you have to create a new action to do this. So it's like there is like an intermediate step, and that has to do in part about how the JavaScript model works. So this kind of, you can imagine that the thing is redrawn, and then this task is put like some of the on some kind of stack or list of things to do, and then when this is done, then the new thing happens. So that way we don't block. So we are not blocking this thing. So Miso sort of takes this idea of non-blocking and just does it this way. But in practice, what you have to remember is that when you have an action which has some IO, which has some effects, then we need to have like a new action. So essentially, let's see how it looks in this case. So we want to do a random to do. So yeah, I'm gonna just have I don't know, a few random things which I could do. I don't know, like hello, and we are supposed to be in Munich, so of course we say hello, and you know, I happen to know Spanish, so I say hola too. So those are the strings I want, and yeah, and I want to get a random number from 0 to 2. So that's, you do it with random Rio from 0 to 2, and this will actually give me an index, and I just get the value in that index. Okay, this is like the super not so clean way to do this. I know 0 and 2 are just hard coded, but just, you know, we get a random element of the list. That's the text, and then I'm gonna get the time, and you get the time by getting get zoned time. That's, I just had to look it up because I always forget about the time API, and then I actually don't want the time itself. I just want a string. So I can show it. But remember, we are using Miso strings, which are like the native JavaScript strings. So I need to write to Miso string and also to import it to Miso string. Cool. So now we have it, and now we can have, okay, we can have an ID being just the time. That I hope nobody clicks as fast as, you know, being up to the same millisecond of thing. The text is gonna be like the text, and then add and the time. So that's the new text I want to do. And then what I'm gonna do is just you know, now I have my thing. So like the new list item, it's essentially gonna be this thing. So it's gonna be a new list item where I put the LID and the LI text, and then I started with not done. So yeah, can I do this? I can do this, but I think I need to do it at the end. Yes. So this means take everything except for LI done and put it there from the, so essentially LID and LI text. And now, as I said, there is this thing in which now I have to give back a new action. So I need to create essentially a new action, and this action is what ultimately will add the thing to the model. So I'm gonna add like a thing which is gonna be add to do. It's gonna have a new list item, which is gonna be a list item. And this add to do is gonna be like the super stupid thing in which I just add to do with a new list item to the model, and that's gonna be like no effects, but put the new list item at the end. So again, like not the most efficient way to do this, but that's enough to being able to say, well, when I'm done, just add to do with the new list item. And that's, you know, it's maybe it's a bit convoluted when you start at first, but as I said, it makes sense because that ensures that we are not blocking the thing. So we call random to do, and this actually like as I said, puts this thing in the list for execution, and when it's done, there is a new change to the model. So let's see, we have this thing, and now there is one thing which is missing, which is that I want to have a button. So I want to have a new button here, which in the header, which when I click it adds changes the thing. So I'm just gonna go and add it here in the next things. I guess I should actually I can just actually copy it from the. So you have in case this was not clear, you have all the things here in the web thing. So I can just go and copy this. That's gonna be much faster than just going through the whole thing by hand. So that's the new thing. So here it's quite similar to what we had before. We had a button. You need to put it into a form, and then when you click, then we raise this random to do thing. So let's build it, and let's hope it builds. So I never know what to do when things are building. You know, I should like be able to play some instrument and harmonize with my new things. I mean, later you will be able to do exercises, but now, yeah, I don't know. Oh, I managed to write this wrong. Okay, you see. Now you should hear, like, you know, when you have this cartoons, and then there is like meow meow, like this kind of sounds. For next time, I'll buy myself a keyboard with all these sounds. Good, and then I managed to do it wrong again by forgetting this. You can see this is all live. I mean, there is no way we could have pre-recorded that, right? That's impossible. So linking setup, I hope the setup, it's okay. Yes, compiling, linking, yes, it's gonna work. So let me open it. And then I need to show you the screen, which now features this beautiful button, random to do, which we hope that when we click it, there is a new thing. Yes, Hola at this time in UTC+2, and I do it and it says hello. So, I mean, it's kind of working, and the other thing is also working because it turns gray. You know how awesome it can be. So now that you know all of this, it's time for you to do some exercises. So you can now work on this. I'll leave it here, and then if there is, so if you have any question about what we've seen until now, feel free to type it into the chat group. Otherwise, we'll go into the Slack, so we can. I think that's easier to chat. And yes, as I said, that's about building tic-tac-toes. So it's all in the exercises folder, and the README contains the instructions. So I can actually sort of they need to find some way to do like I wanna, yes, now okay, now so you have here the exercise, and here you have all the information to what you need to do. So that's for the whole workshop, but now like being able to show the board, click on the tiles and finish the game, and even the new game, it's gonna be more than enough. I mean, I think you will need more than 20, 30 minutes. As I said before, I really want this to be a Miso workshop. So the main contains a lot of things already done, like things to check when you've won, and a lot of the HTML is completely given to you. Good. So let's go back to building our Miso application. I hope you've enjoyed these first steps with the tic-tac-toe. You have plenty more time to keep doing the rest. So, well, okay. So I think that the very obvious next step now is to actually have to-do items which we can write down instead of like having random strings. So how can we do that? And this is something which sometimes it's a bit hard to see, to grab at first, because we usually think of the text box having its own state, and that's okay, but we have to reflect that state on our own state to be able to manipulate this afterwards. So let me show more concretely what we have now. So now we have this. I'm just gonna continue with the same thing, but now I'm gonna have two pieces of data in my model. So I'm gonna change this type to data, because now I'm gonna have some model. I could also use a tuple, but I figure out that this makes the code a bit simpler. So we have the items, and then we have the new item text, and that's going to be the text which is going to reflect, that's the field which is going to reflect what we have in our text box. So let me just have this, and then deriving show an EQ. That's useful for later. And now my initial items are no longer a model, they are a list of list items, and my model is no longer only this, it's this, and then an empty string, which is what the text box does. And now now it's when things get a bit hairy maybe. So let me first introduce this text box. So I'm gonna do this by adding it right before the button. So this is going to be, yeah, I think, yeah, this should be better like this. So I'm gonna just add some new input, and you can do this using input. So again, maybe I should copy this instead of writing it down. So I have it here in the second part. So I have here my whole form. I already had the form like that. No, sorry. I had here my form. So let me copy it here. That this is going to be whole form, and I'll now explain what's going on. So it looks that I've done a lot, but actually I just added this input here. So this input is going to be a form, a text box in the form, and this is going to reflect the current value. So I actually need to bring my model here to be able to access this. So let me bring it here. So I have the value of new item text, and when I change, I'm going to have this new change new item text action. By default, when I have onChange, this onChange gives you the text. So I'm using here the partial application of new change new text item. This action is, so this will rise an action which is here, which is change item text. I don't know. I could just say what's the new text, insert a string. So again, this is one of the another convoluted part. It looks a bit weird because what happens is that so there is a piece of state which is the current text in the text box. When I print the HTML, I actually need to say what is this new item text as the value. So it's reflected in the new visualization of your data. But also when this thing changes, then I have to, this rises a new action, and this will ultimately change my model. So I need to add something here which says update the model, and when I have some change new text item with a new text in my model is gonna be the same thing, but the new item text is going to be the new text. So this, as I say, it's at least when I saw it first time, it feels like a bit convoluted. Why I cannot have the state being just in the text box and somehow being able to grab it. And you could actually do that using some side effects in the effect mode. So you could actually go to the DOM and query it. But this is the sort of the right way to do this. It's to make the thing being part of your state. So this new item text, it's gonna be now part of your state, and you keep it in sync by doing these two steps, by essentially saying when I show my input, then the value is gonna, so what it's in the text box is gonna reflect the current value, and when this changes, so when there is an onChange event, I'm gonna raise an action, and this action ultimately it's gonna change my model again. So this is what in React, in this JavaScript framework, they call a control form. So you're actually controlling the values of the form as part of your state. And in there, you can actually be a bit more subtle, because as I said, in React, you can have local state, so you don't actually need to expose it to the whole state. But here in Miso, you really need to make this part of your state. So my usual recommendation is to essentially split your model in two parts. So your state is going to be like your actual data model plus a bunch, like another type maybe, which holds the state of all your forms and all of this. So it's sort of, I mean, for me, it's kind of clear that items and new item text are like different pieces of a state. One is like my actual data. The other thing is more like the state of the application proper, like the state of the UI. So once we have this, we actually are able to keep these things synchronized. So, well, that's all we do for now. Just before I forget, I also need to change here, because now I'm not talking about the model. I need to change this to items of M, and I also need to change this in such a way that the items are the items of M plus the new to do. So that's to be able to compile. So hopefully now I will use Nix build, and I actually found in the meanwhile something to do while this thing's built. So I'm gonna show you nice books about functional programming you should read. Little Prover, cool book by Daniel Friedman and David Trinh Christensen. This shows you how you can do dependently typed programming from the very beginning. Really cool book. Yeah. Oh, I forgot to import null from Miso. Great. So yeah, I'm doing something I forgot to tell you. I'm also disabling the button if the text box is empty. So yeah, so let me for now disable this too. So this is something I just said. Well, this is disabled is my new text item is null. So if the thing is empty, I don't want to show this. So as I was saying, it also features nice illustrations done by somebody. Create a new error, which is that I also need to have items here. Will I ever do live coding again in my life? I don't think so. So yeah, nice book. You know, if you have some time, it's a nice one to read. Oh my God, that's too terrible. I think now it's actually going to work. I'm hoping. Oh no. What's the problem now? Yes. Okay. Yeah. So. Well, I know this will take time, so I have a whole stack of books to show you. Good. Compile and link in working. Yes. So once it links, then I can open it. I can show you the result. So again, now you maybe cannot see it, but now I have to do this, and you see this is disabled, the button, so it does nothing. If I say hello, then this is enabled. I could click. Now when I click it, it does nothing, but you can see here that we are actually sort of now controlling this view. So this is actually reflected because we can see that, you know, this check which disables the button when this thing is empty actually works. Of course, I'm not doing, if I have a space or something like this, it still enables the theme, but you know, we'll get there. So that's the main point I want you to get from this new version, that when you have forms, you actually need to control them, and controlling them means making the values part of your state. So in the same way that we had these checkboxes being part of our state, this was actually part of our data. We need to make this thing part of our state for this whole idea to fly. So let's maybe close a few of those for the next time, and let's finish what we had started. So now I want to show the code again. So now I need to do something so that when I click, I have a new action. So when I click the new to do button, this action fires. So now I have to say how you update the model with this new add click button. So this is what's gonna happen, what we wanna do. So we could just make it kind of easy and just update it here. So add the new thing, and the important that now it may be more clear why we need the control form. That's because we need to be able to know what is the value in the text box as part of our update model, and our update model is something which can only look at the model. So we really needed this new item text to be part of that, because well, that's the only thing we can do. That's the only place we can look at to get this information. So yes, but there is a problem. We need a unique ID here. So what I'm gonna do is to take part of this thing, and you know, instead of having a random to do, which I no longer need, I'm gonna have an add to do click, which will create a new ID based on my time, on the time. That's one thing we can do. And now it's just that the text is gonna be what we had as new item text. So this is part of my model. So let me pattern match here. This creates a new list item, and then when it's done, it's done. And in order to not, so at this point we can already say, well, my model is what we had before, but I want to change, I want to make the new item text being the empty string because I want to start fresh again. So yeah, that's essentially what we want to do now. Redundant brackets. So what we've done here again is, first of all, we've controlled the form, and as I said, controlling the form means that we are going to reflect in the context of the text box as part of our state, and we did it by introducing a new field here as part of the model and introducing a new action, which is change new item text, which will be fired when we do it here, when the value of the input changes. And that's how we keep things in sync. And then the other thing is similar to what we did before, which is we had a button which fires this add to do click, and because we control the form, we have the new item text available as part of the add to do click, so we can use it here. And just because we, it's simple and we can reuse the implementation before, we can, here we are actually creating a new ID by using the time, but we could do it, I don't know, randomly or whatever, and using this as the ID. This is, a step I would say we don't really need to take, but that's also, the simplest way to have a unique ID in a simple way. So let's see whether it builds or I need to rebuild 10 times as before. In the meanwhile, Purely Functional Data Structures by Chris Okazaki, a real classic. So this teaches you about data structures which are nice when you use laziness. So if you really want to understand laziness, this book is really for you. It takes some brain power to read this, but it's a really cool one. A bit hard to get in Amazon these days, but well, here it is. Good, it worked. So let's open it. Now I'll share my Firefox window, and now when I say hello here and I click new to do, it appears there, and I can click it and then click it. Wow, I mean, it's like now we have forms and everything. We can do any kind of typical application with lots of buttons and things. And as you said, and as you've seen, when I click hello, then it also my new item text went to the empty string. So this disappeared and the button was disabled because the button is only enabled with this thing. It's not empty. So we've built something slightly bigger from this. Yeah, so that's all you need to know about forms. You need to control the inputs. Every time you have a text box, or every time you have like checkboxes, either they reflect part of your data, or you need to make them part of your data. Cool. So it's time for more exercises. So again, same place, same exercises. You can just keep going. You don't have to do all of them. You can just skip some if you don't want. But the one we have for this part is actually, it asks you, well, instead of having like player 1 and player 2, make those players being you can have like player 1 and player 2 having their names, and then you reflect this. And the nice thing is, well, the harder part is that you don't really want these names to change while the game is running, so you need to have some kind of extra state in which you keep, well, is my thing running, then maybe I should disable the text boxes so things cannot change, and so on. So have some fun. In 15-20 minutes we'll come back with the next thing, which is how we can store all of this in such a way that now we've worked really hard, but if I go here and then I refresh, everything is lost. So not so nice if you really want to use this in a real application where you want to keep the data. So next the next step is going to be adding local storage, so storage in your own computer using the browser local storage. And then the next step is going to be sending this over the network using servant client. So yeah, but in the meanwhile, let's exercise for a bit. Hello again. Yeah, let's go back in action. With the new steps, which I said was not having everything, go away when you take all the time to type all of this and then you write the new to do, but then you reload the page and it's gone. So we're going to use something called the local storage, which is some storage you can have in your browser. So for all these APIs which are coming from JavaScript, you have this Mozilla Developer Network, which is an incredible resource. So that's the where it tells you how the local storage works and so on. And what we'll see is that in Miso, this kind of APIs provided by the browser become effects. So as I mentioned, effects are essentially things you can do in the IO monad in the browser. And local storage is in particular what file system looks like in something like a browser. So you can see here that that's a quite a simple API. You can ask for the local storage given a string, and or you can set it. That's essentially it. Or you can remove or clear things. So let's see how it looks like when we go into code. So we're gonna add the facility to keep this information there. So let's look at the code. The first thing we have to figure out is that when we start, now we do nothing. So the first action, the initial action, is none. But we now want to do something, so we should add a new action, one initial action, which is going to be, in this case, I call it load items. So this I add it here. So load items. Okay, and now instead of starting with initial items, I'm going to start with an empty list. I'll hope that these items, so I need to write something there. I could have a maybe instead, but just to keep things simple, I'm going to start with the empty list of items, and then things will come from the local storage. And then hopefully at this time things are just sort of know what's going on. So I update my model, which is like load items in my model. And remember, you first return the result, and then you do the effects. So that means that, well, here now we are not going to do anything, and then we are going to start getting our things. So here we just need to call get local storage. For this, I need to import the corresponding miso.effect.storage. Yeah, autocompletion doesn't work as so good because, well, you can sort of make it work with Nix, but I haven't done that, so sometimes things just become red and there is nothing you can do. So, and the API in this case as well, you can have a left if it's not there or there was an error. So in that case, well, let's say that the new items we have, so the initial items are gonna be these initial items. Maybe I should call this like default initial items instead. So I'm gonna let, if I have an error, that's gonna be my default initial items. And if I actually got something, I got some items, then I'm gonna yeah, those are the items I'm gonna have. I'm sure I can write this down in a nicer way, but just, you know, I either return what I got or I return the default. And that's where I, again, need to add a new action, which is gonna be what happens when we end up updating the model. So I have here like set initial items. Like the initial items are gonna be a list of list item here. So I end up by saying pure set initial items, and that's how I load things. So I hope this wasn't, now that you know what's going on. I mean, essentially, I'm using the same idea. I'm returning what I have to do, and then I do my actions, which in this case involve the local storage, and then in this case, the local storage can return a left or a right, and at the end, I set the initial items, and of course, I need to update to set the initial items. So I need to say no effect, but my items are going to be the initial items. So yeah, now I'll still show you a book, but I know this won't work, but I think it's interesting to see why this won't work. Hopefully the error is going to be what I expect, but you cannot trust your errors. In the meanwhile, programming with higher order logic, that's not Haskell related, but if you ever program in Prolog and you wonder how Prolog would be if you could use like for all and exist and things like this, that's what higher order logic gives you. So, oh, too bad. Yes, now I know what I need to do. I need to have here like the key under where this thing, I forgot. That's one of the error I wanted. But you see that the static type, and it's actually catching many of the things. So imagine writing this in JavaScript and having this just, whoa, what's happening now? Oh, now it's the error I wanted. Oh, I didn't have time. I'll put it back into the pile. So it says, oh, wait a minute. To put things in the local storage, I need to be able to turn it into JSON. I mean, in this case, I need to turn it to coming from JSON, because the local storage in your browser is actually recording JavaScript objects. Only if I could turn things into JSON automatically. And that's where, again, having Haskell is just such a breeze, because I can go and say, well, I know how to do that. I can just add, well, it was already there. I can add ASON. And then I'm going to do the typical generic derivation. So I add a few more of these, like derive generic, and write any class. And then I need to import here data.ason and GHC generics. And that's the usual way. I mean, that's on the ASON documentation, how you can just automatically, by using GHC generic, which is like one of the facilities for doing data type generic programming in Haskell that comes built in the compiler, you can just say, well, I derive generic from JSON and to JSON to this thing. So these lines, okay, I maybe I was a bit fast, but essentially all I wanted to do is to derive automatically from JSON and to JSON. And if you check the documentation, to do this, I need to derive something else, which is called generic, which is like a type level representation. It's like a type level representation of what this type looks like. And if I do this, this code can be automatically generated. And then the rest, what's essentially boilerplate, if you write this down as I did, it will tell you, please enable extension derive generic, which I already did. Please enable extension derive any class. I did it. So that's, I'll just, whatever a compiler tells it. And then of course you need to import the things. So let's hope it builds now. the Mingwell, as I was saying, Lambda Prolog is a really interesting thing. I don't know. It's like, as I said, if you ever did the logic programming, this is an interesting book to see. Good. So let's see. Now it worked, but we won't be able to see anything. I mean, I can show you the browser. Spend 30 seconds changing the zoom windows, but we are just loading things. But we never put things back in the local storage. So we will always get like the left case here. And get the default initial items. So, you know, until we don't do something else, why do this? So, yes. So, where should we update the model? Well, we should update the model essentially when we add it to do, right? So, so that's where we want to do this. And also when we toggle the state of the items, because this is part of the thing. So yeah, I'm gonna do essentially that. So before, when I toggle things, I said there is no effect, but now actually there is some effect here. And this effect is update the local storage under key items. No, sorry, set local storage and under key items, and then I write the new thing. And that's when this known function turns out to be quite useful, this known action, because now, okay, we've done this, so we toggle the state and then we change it, but okay, we are done. We don't want any more change in the model. So yeah, we can just say we don't want to do anything else, just pure none. And something very similar happens here when we add something to the to-do that's here. So let me essentially change it to have the same form. So the new items are this thing, and then I can copy this. Of course, instead of copy and pasting, maybe we should introduce, you know, like an actual function there. But well, that's something we can do if we really want nicer code. But we only have 1 hour left, so we don't have the time for nice code. But we have time to talk about the fun of programming, which is also an older book. Oh, it's linking. No worries. Next time. So now, hopefully, I'll be able to show you how these things. Oh, okay. The storage now it's empty. So it gave me back something, and now I can do like hello, and hopefully this will add the to-do, and hopefully when I refresh, oh. That's weird. Oh, you didn't see it because I didn't share the screen. But yeah, there was nothing, and then I did hello, and then yeah, the hello it's gone. So there is some problem here. Let's see what's going on. So when I set the items, those are the things I want to check. If I get the storage, that's the thing here. So get local storage seems fine. Okay, this is really weird. Ah, yeah, sure, of course. Yes, I forgot one step. I need to ask it to load items as my initial action. Otherwise, I will just start with the empty thing. So it seems that you know the destiny really want me to talk about the fun of programming. So yeah, Jeremy Gibbons and Hugo de Moor have this is a nice set of articles about how you can use functional programming to solve problems in a different way. So that's from different authors. But you know, I find it really nice. It uses like very simple Haskell, so it's really like really Haskell 98 Haskell. So yeah, very cool to read. And now we are finished, so I can now open it and show it. And now you see that when I don't have items, there is nothing shown here. I can add a new to-do, hello. I can even click it, and then when I refresh, let me just click it again, it loads the thing from local storage. So you know, we've now have something which works on local storage. I had one small little I also want to do, but I think I'll skip this. So it's nice, but this has a problem which right now it's not very local storage is super fast, of course, because it's in your own computer. But what happens now that we are going to move to do this request over the network? So what we would really like is to have some kind of loading toggle, so that you cannot click, for example, new to do when things are loading. So you want to show like a spinner or something. So actually, yeah, let me do this because it's not that hard. So we can just say, okay, let's add a new element to our model, whether it's loading. At the beginning, well, it's not loading, but when we do load items, then I'm loading. So it's loading is true. And then when I finally get my initial items, is loading is false. And using this, what we could do is, okay, in my header, instead of having this form, I could say if is loading, then I show like a div with some text like loading. I don't know, nothing too fancy. Otherwise, I go and show this thing. So again, just a reminder that Miso code is just Haskell code, and we are creating this, you know, using Haskell. So we can just write whatever any control structures we want to create this thing, which as I say, find quite nice, because essentially you don't need to have like a template in language. Haskell is your template in language. Yeah, and now the is loading is, yeah, this is true, this is false, and so on. So I'm just doing this in preparation for the next step, which is doing requests. So in order to do requests, we are going to use servant client. So servant is one of the best known REST HTTP frameworks in Haskell, and it has this idea that your API, your REST routes are actually encoded on a type. So for most people, what you usually do is to create a server. That's, I think, what most people use servant. So I actually here have a server built in with servant, what we are gonna use there. And you don't need to understand too much. The main thing I wanna stress is that your API becomes a type. So this is essentially telling us that my server knows what to do when you ask for /items, and it will give you, and you do a get request there, and it will give you a list of list items encoded as JSON. It also knows what to do when you do a post to items, and then then you pass a list item as in the body. So that's what we're gonna use to write a new item. So yeah, to write a new item. So we are gonna do a post. I guess if we use REST directly, we should use put instead. But yeah, I always forget about these little things. And then we have toggle, which will take the ID of the list item as a string. So it will have like toggle slash and the ID, and then we're saying this is a post request, and we'll toggle the thing and give back the new list item. And the implementation is not important. This is actually using an in-memory list to do this, using software transactional memory. So that's also a cool thing we could talk about another day. But the key point is that my API is a type. And if you see, I'm actually copying the list item type from before, because I just want to use this as the serialization, and I'm using here the same trick of using from JSON and to JSON. The only slight difference is that instead of Miso string, I'm using string, because Miso string is only for JavaScript, and here I use string. I could also use text. I guess that would be the best thing to do, but just I don't want to import yet another library. So that's the thing. So why this is interesting is because the same type, which works as the API for a server, could also work as the API for a client. So I'm just gonna go and copy this API, I don't know, somewhere here. I have here let me remember where I had this. Yeah, so I don't know, somewhere here. So important. I have my API here, but of course I need a bunch of imports for this to work. So first of all, we need to enable a few language extensions, which you also need to enable. You always need to enable when you are using this kind of type level programming like we do in Servant. So we enable data kinds, we enable type applications, that's going to be useful later, and we enable type operators, because we need those to write the servant routes. And then we need to import a few more things. So import data.proxy. And I'm doing this fast because you can get this from using the servant documentation. So I see no point in explaining how routes work if that we don't have that much time. So you need to import servant.api. You need to API. You need to import servant.client, and that's where the cool things come. So you import a special client for servant which uses GHCJS, and we'll see. You also need to import an internal module because one of the functions we need is not exposed. So that's not super important, but these two things are coming from a special version of servant client, which is called servant client GHCJS, which has the only slight problem is that it lags behind the current servant, but it still works. So because making a HTTP request hasn't changed between version 0.16 of servant and 0.18. But I don't know. I find this really cool to be able to do it. Yeah, we'll also need from Miso string here. So I'm adding it here. So let me now pause a bit. I essentially added a lot of imports, a lot of extensions we need. And I copied this API from what I had before. So you could also like read the API or whatever, but if you control both the server and the client, you can actually have like a common module. So I haven't done it because it would take extra time to explain, but you can create like a common library which is shared between server and client with the common type definitions, and you know that always your client or your server are sharing the same definition, which I think is a really interesting way to proceed. And then in order to use servant client, we need to create a client, and this will give us one separate function for each route we had there. So actually I have it here, but each root lives always in this client M monads and gives you back the information that the roots tells you. Items, so add item, which is my second root, takes a list item as an argument and it gives you back nothing, so no content, and toggle item takes a string, so a string, and it gives you back the list item. So after writing the types, which, as I said, are derived directly from the API, and I'm writing this only for documentation and to sort of show you how actually you can read the roots as functions. The magic is that using servant, you can do the following thing, which I find always, I mean, I understand how it works, but it still feels magical. I can just pattern match on these things and say, please create a client for this type level API. That's where I'm using type application. So I'm using the proxy to say to client what type I want to create, and just based on the form of my API, servant client is able to derive the right way to call things and everything, and which is essentially what you would expect wrapped in a client M, which is the extra. It's like an IO monad which has some extra facilities in there. Cool. So in order to use it, I just need to add one thing else, which is client, saying where my server is. So in my case, it's gonna be in localhost 8080 and no root at the beginning. So that's everything you need to have a servant client. So now let's use this thing to create, to change our local storage into proper server storage. So yeah, let's do this. So the thing is going to be in load items. We no longer have get local storage. What we are going to do is to run client and origin. That's the call to run like a client. You read this as run client M. So that's what gets from client M, which is the servant monad, into the actual IO. And then this origin is because I want to use my my own client environment. There is another version called run client M, and that's for a very specific case, but which is quite a common case in which your client is served from the same URL as your server. So that happens quite often, that you have essentially just one server, and then if you go to / you get back the client, and then your server is somewhere else. So for that case, you can just use run client M instead. But because I cannot use it because I'm in a weird port, I need this version. That's why I needed this internal module. So I just changed this. Instead of local storage, I now have this storage there, and nothing else changes. So that's the if I didn't do anything else, well, the things will still be saved in local storage because I haven't changed them, but I'm already getting things from there. So why not change the list items to go there too? So if I toggle state, remember I had set local storage, but now I wanted to instead run my toggle item. So I can do the same as before, run client and origin. What is the thing I want to do? I want to call toggle item. That's this root here, and it needs a string, yeah, my ID is a Miso string, so I can just turn it into a string by using from Miso string toggle LID. And now I just need to do the client environment. So those are all the changes I need to do in toggle state to be able to call this thing. And now in this add to do click, I forgot to, when I add the to do, I'm here setting this local storage, but now I want to add the new list item. So again, yeah, I can just go and run the thing I need. So let's run client origin. I want to run add item with the new list items and using the client environment. So hopefully all these changes, which is essentially replacing the local storage by the calls to servant client. And again, the servant client is actually not written by hand, has been automatically derived from the API as a type. That's the idea that sort of servant brings in, allows us to do this. So let's call next build while I show you something which is not Haskell, but it's also quite interesting, which is the main modeling made functional by Scott Washington. I don't know how to pronounce the name right. It's an F#, but it's a nice book about how you can, introduce like functional things. I'm forgetting something here. Yeah, I just forgot to add the package to the build events. So yeah, as I said, it's a cool book. I like it especially to introduce this to people who might not know too much functional programming. It shows how you can use these things. Oh, great, a typo. So list item here. So yeah, it's as I said, it's a cool book. And now let's also see how can I run, how can I open a new terminal, because I need a new terminal. What's going on? Get items. That's the reload cycle. I think if you know a bit more Nix-fu, you can actually make this reload cycle be much smaller. But yeah, that's what we have here. So compiling, linking, yeah, good. But of course, now if I run this, it won't work because there is no server running. So actually, we didn't handle the error case. I will show you how we can handle the error case later. Yeah. So let's see. I want to open a new server, and if I remember correctly, this was in code for request, and I can just cabal run. Yeah, if I but I need to run cabal run and so it stays there. Yeah, now it's building. Yeah, so the server is running somewhere in the right port. Hopefully it's the same port I ask it to run. I have my notes here, so I can, yes. So now if I go back to my ongoing thing, I can open the result, and yeah, let me show you Firefox. So I mean, it works in the sense that I can add things and it will get back to me. But the cool thing is that if I open the developer tools, sorry, the Firefox is in Spanish. If I open the developer tools, I can, yeah, I can just go to the network thing, and you will see how my request was done. So I did a request to this thing, and I got that response, which is an object and all of that. And this serialization to JSON was automatically derived using ASON and generics, which I think is it's quite a nice thing. And if I have something like clicking, you can see here the post thing going there, and the JSON returning that now it's done, so now it's true. So in a in a proper web application, you would actually not update the flow. Maybe you will just patch this update until this thing comes back and it's actually reflected on your thing. But I hope you can see that we can do all these requests quite easily using Miso and using servant clients. So we can actually, as I said, servant is usually used more to do servers, but the client facilities are also quite nice. So okay, so let's give you a last part to do some exercises. So because we had not that much time, I decided to condense these two things that have a block inside. Essentially, what the next exercise in tic-tac-toe asks you to do is to save the games you've played in tic-tac-toe and who has won. So yeah, in 15 minutes, at 5 past, we'll come back for the last block, which tells you how you can actually use routing. And the point is not so much that you know about routing, is to explain you the last piece of the Miso puzzle, which is subscription. So that's how you can essentially bring events which are not coming from the forms itself, they are coming from other places. So yeah, see you at 5 past. I'll, as usual, leave the slide with the URL to the exercises. See you then. Hello again. Hope you're ready for the last block for today, which is where we're going to talk about the history, how you can manipulate it, and this is going to be my way to talk about subscriptions. So if you've noticed, in many modern web applications, when something changes in your URL, so you add hash something, and then the web page changes, but there's no a whole refresh. So how do you access this? How does that work? Well, the thing is that there is a special API in the browser that's called the History API, and that allows you to actually manipulate and reflect on the changes to the API. But there is one thing which set this API and this kind of events for when the URL changes, essentially, this set is apart from what we have seen for forms, is that it's not tied to a specific form. I mean, this is coming from the browser somehow. So it's as I said, you cannot say there is the button with changes and have it unchanged on the bottom. So for this type of generic events, let's say events which come from the browser, that's how I think of it. Miso has the subscription system, and let me show you what are the different subscription which comes built in with Miso. So if you see here is the Miso subscription, and it has several submodules. You can see it has the history, but things like the keyboard and the mouse, which again are not tied to a specific. So if you want to control, you're maybe developing a game and you want control when the user presses up or down, that's the thing you can use. Also, you can use this to control things about the window itself and also about WebSockets. So if you want to do a call using WebSocket instead of HTTP, and something called SSE, which I really have no clue what it is about. So anyway, what I want to show you in this last time is how you use subscriptions. And as I said, subscriptions are essentially like events coming from the browser. That also means that if we want to do something like doing something with the URL when it changes, and we want to reflect on this, then we need to control that variable. We somehow we want to keep track of the current URL we need to control it in the same way that we control the forms. So that means that we need to keep this, we need to follow the same steps we had to control the text in a text box. So let's do that. So I'm gonna go to my code, and then what essentially I want to do is to be able to write either my URL or my URL hash about, and when I show about, instead of like my to do, I want to just, you know, show some description, some text, something like this. So this is like a simplest example I could think of to do this. But I said we need to control this URL. So I'm just going to do it by adding yet a new part of my model. That's when maybe you see that I think at this point is when it starts to make sense to really separate like your actual data, like the items, and have a separate data type for your like your UI state. I'm just keeping it like this to keep it simple, but as I say, at some point I would just put this into a special type like UI state to hold all of these things. And this will every time the URI changes, the location changes, I want this thing to be updated. So I need to create a new, in the same way that I had for change state, I need to create a new change URI in which I have the new URI. So this is the new thing, and yeah, my model, whenever my URI changes, I just do no effects at my current URI is the new URI. So that's essentially what we've done before. We add a new custom, a new action, which is called when things change, and then we update our local state in which we control the value of these things. Of course, the question now is, how do you get those events in the first place? Because in the other case, we use the events from the text box, but here, what you do? Well, you go to what we haven't touched yet, which is the subscription here. So that's the subscriptions you want to use. And in particular, what we can do is to use a specific one. So you can find it by going at the documentation here and saying, well, I want to know my history. What is the subscription? Well, there is this URI soup. So URI soup, you give it a function, which given the URI will take an action, and it creates a subscription. So this subscription is, as I said, a way to listen to the changes and every time there is a change in the URI, this thing is gonna be cool. So yeah, I can just go back to my code and say, okay, let me subscribe to changes in the URI, and I'm gonna call change URI. Great, that's awesome. The only thing is that, okay, that's great, but we also wanna know what is the initial URI. What is the thing in which we are when we begin the application, because this change URI is only called when it changes. It's not called for the first one. But here we can also play one trick, which is the fact that this thing is in IO, and there is a special action which is get the current URI. So I can just call this, and now I have my current URI, and the magic of the ... means that because current URI is in a scope and it's the same name as in my model, it will automatically be added here into the initial state. Oh no, sorry, not here. It should be part of the model, so it should be here. So my current URI is going to be part of my model. So, oh yes, and that's something I forgot. Otherwise, I can no longer have my model here because current URI is not in scope. So yeah, now everything is right because yeah, current URI is only in scope there. I could also have created a function or whatever, but I think this is good enough. So the setup looks slightly different, but again, what's happening is exactly the same as when we had the text box. We had to get the initial value here. That's like the small quirk we need to do. This is what goes into the initial model, and then every time the URI changes, then change URI is called. That's specified in the subscription here. So that's the subscription here. And then we do something. And for example, what we could do now is, if we had the URI, we can inspect it and do something different. So I have here an example of what I could do. So if the URI fragment of the current URI of M equals about, then I don't know, show like some text. So I show it with a nice font, but I just built for MuniHac 2020, something like this, and else I show the other thing. So here what I'm doing is I'm inspecting the current URI. I'm getting the URI fragment, which is everything after the hash. There is like many things to do this, and well, that's essentially what I want to do here. And let me also add on the same go. So here we had like the header. We want to have like a button, like a link to this thing here. So I can just add a button that's using. So I need to add some of these things, otherwise it doesn't show. And then my reference. So I go to hash about, and then my text is also going to be about. So the thing is, this will create a link to hash about, and then when I click it, the browser will create an event saying, well, the URI has changed. The subscription system will take this event and turn it into the action, change URI, and then, well, the whole thing is going to be re-shown with this new thing. So let's hope it works as usual. My almost latest book is Software Abstraction. This book teaches you Alloy, which is a nice tool to do formal modeling. So you can model your software using it, and you can figure out, do exploratory testing over it and things like that. It's really nice. It's actually the second edition, so I guess it went cool enough for the first one. And it's actually a quite nice idea, something to read and think about how we model software. Cool. So it finished, and I have it here. Let me show you. So now we have this about thing in the middle. That's the link we created. And if we click about, the URL changes. So you can see it. I can, let's see how I can, here the about is added to the URL. And then, well, because we said in the view, if the URL is about, then do this. This is nothing which you can notice easily on the video, but there was no refresh. So if I go back, the thing is not refreshed. It's just because it's the same URL but with a different hash. Then the browser has sends a new event now which says, oh, URI has changed, so do whatever you want. And here we said, well, if it's not about, then we want to show this thing. And people use this to show, I mean, you could imagine having a URL to filter or different thing. We're just using about, which is the simplest thing we can do. And something which is incredibly cool, and I think I can show you by going at the Haskell Miso. So just to end thing, haskellmiso.org, it's where the documentation is, and there is, so if you go into the docs, into the README, which is the main documentation you can use, they have here an example of router. So that's what we are doing. We're essentially having routes. But the thing is, they've gone even a step farther. So I've shown you how you can do this by hand. And for some things that's easy. But if you really have a lot of URLs, you could also think of the URLs as servant routes, because they are, after all, routes. So they've been able to take, the servant API and turn it into a way to route things in your application. So if you use like React or many of these things, they actually they have their own React router thing, because that's kind of something which is done quite often in front-end applications. And as I said, you can go into the source of this. I don't have time to explain it fully, but the point is that you define your routes also using servant, but instead of returning something like post, you return a view. That's the type. And then, it's here. The model actually runs the route. And here, if you've done some servant server side, you might recognize that that's how you define like a server with two routes. But here, the servers are actually giving you HTML elements. And the cool thing about this is also that if the routes have arguments, this is like in servant, it parses the route and gives you back the information, so you can have even more powerful routes for an easy price. And at least, I like using servant in the server side, so being able to use it to have both my client side rendering and both my client side requests and my client side rendering seems like a cool thing to me.